Hello student, warm welcome in this YouTube channel. Question from JEE Advance 2019. A ball is thrown from the ground at an angle theta with horizontal with an initial speed of u0. For the resulting projectile motion, the magnitude of average velocity of ball to the point when it hit the ground of the first time is v1. So student, v1 is the average velocity in first hitting. So the distance covered in first hitting is equal to the range of the projectile upon time of flight, and range is what? Ux into t upon time of flight. So tt cancel, we got b1 equal to ux, which is the horizontal component of u0, which is u0 cos theta. So ux equal to u0 cos theta. Therefore, average velocity in first hitting is u0 cos theta. Now, similarly, the total average velocity in this is v average equal to total distance or total range upon total time in question. After hitting the ground, the ball rebound at the same again theta but with a reduced speed of u0 by alpha. Here speed is u0 by alpha, so the v2 become u0 by alpha cos theta. So this is v1 by alpha. Similarly, v1 by alpha square, and so on. And here time t1 equal to 2u0 sin theta upon g. Okay, and here time is in second, t2 equal to 2u0 sin theta upon g upon alpha, and this is what? t1 upon alpha square, because when we put t1 equal to 2u0 sin theta upon g, which is given to us u0 upon alpha. Okay, here 2t is equal to alpha. Similarly, t3 in this third section is t1 upon alpha square, and so on. So v average equal to total range upon total time. It means r1 plus r2 plus r3 plus r4 in different sections, the range, sum of the range upon sum of the time of flight t1, t2, t3, and so on. And in the last, it is said that the average velocity of the ball for entire duration of motion is 0.8 v1. 0.8 v1 means 8 upon 10 v1 or 4 upon 5 v1. So 4 upon 5 v1 is the entire average velocity. 4 upon 5 v1 equal to r1 is what? v1 into t1, v2 into t2, v3 into t3, and so upon t1 plus t2 plus t3, and so 4 upon 5 v1 equal to v1 t1, and v2 is v1 by alpha, v1 by alpha into t1 is, t2 is, this t2 is t1 by alpha plus v3 is v1 by alpha square and t3 is t1 by alpha square, and so upon t1 plus t1, t2 is t1 by alpha, t3 t1 by alpha square, and t4 t1 by alpha cube, and so. Now we take common v1 t1 from numerator and t1 from denominator. We got that 4 upon 5 v1 equal to v1 t1 1 plus 1 upon alpha square plus 1 upon alpha to the power 4, and so on up to infinite, because ball is hitting the surface infinitely. Okay, so here t1 is common, so 1 plus 1 upon alpha, 1 upon alpha square plus, and so on up to infinite. Here b1 is cancelled out from both sides and t1 is cancelled out from denominator to numerator. So 4 upon 5 equal to 1 plus 1 upon alpha square, alpha to the power 4 plus, and so on over 1 plus 1 upon alpha plus 1 upon alpha square plus, and so on. This is a geometric progression up to infinite, and sum of infinite term of a geometric progression is a upon 1 minus r. You know this from geometric progression in mathematics. So 4 upon 5 equal to, here first term is 1 upon 1 minus 1 upon r square the common ratio 1 upon r square. In denominator this is 1 upon 1 minus 1 upon alpha. Okay, so this is the sum of infinite series. Now 4 upon 5 equal to this 1 minus alpha, 1 upon 1 minus alpha reached in numerator and this come in denominator. Now we solve it, that alpha minus 1 upon alpha and alpha square minus 1 upon alpha square. So we take alpha minus 1, the middle terms multiplied each other and the external term multiplied each other. So alpha minus 1 into alpha square upon alpha into alpha square minus 1. So this is divided, alpha minus 1 into alpha upon alpha plus 1 into alpha minus 1, a square minus b square using the identity. So this is cancel out, we got alpha upon alpha plus 1 which is equal to 4 by 5. Now cross multiplication, 4 alpha plus 4 equal to 5 alpha. So 4 equal to 5 alpha minus 4 alpha, that is alpha equal to 4. So the value of alpha is 4 in this question. So 4 is the answer. Student, first we got the T1 and V1 in the term of its initial average speed V1 and the time T1. T2, T3, T4, we take them in term of T1 and V1, V2, V3 in term of V1. By using this geometric progression, we solve this problem. I hope you got it. Please like the video, subscribe the channel. Thanks for watching.